In today's demo, we're going to be exploring buffer solutions. As an introduction to buffer solutions, we're going to play around with some acids, some bases, salt solutions, and a buffer solution. Now, what I've prepared here is a solution of sodium chloride, a salt solution, pH approximately 7. I also have a buffer prepared here, which buffers at approximately a pH of 7. Now what we're going to do is we're going to see the difference between a buffer, pH 7, and a solution at pH 7. We're going to add to it, first of all, a base, sodium hydroxide, 0.1 molar. And we'll see how it affects either solutions. Now to see how it affects, we'll add an indicator, phenolphthalein, a couple drops to each solution. By doing that, we'll be able to see color changes. Now, a little review about buffer solutions. Remember that buffer solutions, the whole purpose is to resist changes in pH. The pH will change slightly, but it resists changes in pH. Now, let's take 0.1 molar solution of sodium hydroxide. We're going to add it, first of all, to the sodium chloride. We're going to note the color change and how many drops it takes to get to that color. So let's drop. Notice the pink color? Let's mix. Look at that. One drop and the solution turned pink. Remember, phenolphthalein indicates the presence of a base. So it took one drop to make this solution a basic solution. Wow. Now we're going to add it to the buffer, and we'll see what happens. We got one drop. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've added 13 drops and it's still not turning pink. Remember the purpose of a buffer as we do this. It's to resist a pH change. And it's doing that. We'll explore in a little bit how it does that. 13, 14, 15, 16, 17, 18, 19, 20, 20, almost got 21. Let's do some more. 21, 22, 23, 24, 25, 26, 27, 8, 29, 30. I hope you guys are getting the point. We've just added 33 here, and it's still resisting a change in pH. If we were to take a pH meter and add it to the solution, you'll notice no difference. And we see that according to the color change. Because remember, we're at about pH of 7. The slightest difference, as soon as we get into the pH of 7.1, 7.2, we'll get a color change because we have an indicator. So it's not doing that. Well, let's go ahead and add a whole drop. Now a whole drop is approximately 20 drops. Let's just do it a little quicker to accelerate the process. Notice I've added a whole dropper. It's still resisting another 20 drops. Notice finally, now is approximately 30, 40, 50, 60, 80 drops of base to change the pH from about 7, which was neutral, to a basic pH. Whereas the sodium chloride solution, which was at pH and not a buffer, took one drop. That's the whole point of a buffer solution. Now remember, a buffer solution is an equilibrium with an acid and its conjugate base, or a base buffer, acid, conjugate, or sorry, a base and its conjugate acid. Now, in a buffer solution, it's really important to remember that the concentration of the Bronsted-Lowry acid or base is the same as the concentration for its conjugate. A quick review. If we take a weak acid, for example, acetate, CH3COOH, we place it into solution, it dissociates to produce CH3COOH and H3O+. Now remember that a weak acid dissociates not 100%. In fact, it dissociates so little that the slightest change in H3O+ concentration, or if we add a little bit of base to it, the pH changes rapidly because a weak acid doesn't dissociate. So what we do to make that into a buffer, we take the CH3COOH that we've taken, the weak acid, and we make its concentration, let's say 1 molar. What we'll do later is the CH3COO- or the conjugate of that acid, we'll take that and bump its concentration also up to 1 molar. How do we do that? What we do is we add a soluble salt that contains CH3COO-. A good one to use, sodium acetate. When we add 1 molar sodium acetate to a weak acid solution of sodium or of acetic acid, we make both of their concentrations 1 molar. That is a really quick description of how to make a buffer. And we notice the buffer is doing its job. We're going to take the same two solutions now. Let's put this aside. We have a salt solution, and once again the buffer solution. Now this time we're going to add bromocressyl green, and remember it's an indicator. When the solution becomes acidic, it's going to turn a yellowish color. And you notice the sodium chloride is slightly blue. That means its pH is probably about 7.1. Now, let's go ahead and add 0.1 molar hydrochloric acid and see what happens to these solutions. Remember, in the first part, we were adding a base. We were seeing how these solutions resisted the changes to adding a base. Now we're adding an acid. Let's add 1 drop. Notice the 1 drop, let's add 2. It turned it a yellowish color, kind of an off yellow, pretty fast. Wow. Let's just add a little bit more indicator just so we make sure that we get a bright change. We'll add a few more drops, approximately 10 in total. And we'll do the same to that one. This way we can really see the color change. Notice the color by adding 2 drops of HCl, or an acid. And remember, HCl is a strong acid. We've diluted it to 0.1 molar. Now we have our buffer solution. Now we're going to add HCl. Once again, we're going to see what happens. I'm thinking that you should be able to predict, well, how many drops is it going to take? Is it going to take the 1 drop, as it did with the sodium chloride pH 7 solution, or more? If you said more, you're probably correct. Because remember, the whole point of a buffer is to resist changes. Now, when this pH goes below 7, this solution is going to turn yellow. So we'll add 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Notice we're adding a whole bunch of acid and it's still not changing color. Well, let's accelerate that process. And we're really going to start adding it. Well, this is just starting to change now. I bet you the next set. So far we've added about 60 drops. We're going to go another 20. And notice that, hey, we're just about there. Look at that. Now the solution is yellow. It's changed color. and we've added about 100 drops. Now notice the solution has now turned yellow. It took approximately 80 to 100 drops. Remember, we're not worried too much about the quantitative results. We're interested in the qualitative results. Quantitative being numbers, qualitative being visual. We notice it took about 80 to 100 drops of acid to change this pH. In other words, to take it from about a pH of 7, which is neutral, below into an acidic pH where bromocresol will change color. Now that's pretty cool. Now once again, it took a lot longer for the buffer to change its pH. Now what's going to happen is at the end of this lab, or this little demo, I'm going to show you a number of equations that I've talked about already. In other words, I'll show you an acetic acid buffer with its appropriate concentrations and show you what happens when you add an acid or a base.